Hello, Geometry. This lesson is titled The Coordinate Plane. Well, this is going to go back to some basics of Algebra 1 and even pre-algebra. So starting off here, it's just labeling quadrants and coordinates. How do we label the quadrants and coordinates? Well, first of all, let's talk about the quadrants. Every XY coordinate plane, that's what you're seeing here, is broken up into 4 quadrants. That's why we have the word quad right there, or the prefix quad. We always name them in Roman numerals. Starting in the upper right would be quadrant 1, upper left would be quadrant 2, bottom left would be quadrant 3, and lastly bottom right would be quadrant 4. Don't forget that's IV for 4. Now labeling quadrants. So let's start here with A. Notice with A, it's going to the right. Whenever you're going from the right from the origin, by the way, the origin is 0, 0. Whenever you go to the right, your x value is positive, so it's going over 1, 2. Your y value in the first quadrant is going up, so we have gone up 4. So over 2, and then up 1, 2, 3, 4. Okay? So that is for quadrant A, or it's not quadrant A, for point A. Point B, notice is going to the left. So therefore, our x values are negative. So 1, 2, 3, 4, 5, 6, negative 6. But it's still going up. So therefore, it's up positive 1. That's our y value. C is one more over from B. So that means it's negative 7. But in this case, it's also going down. 1, 2, 3, 4, 5, 6. So negative 6. Okay. Now D, on the other hand, notice it's on the y-axis. So in terms of it going left and right, it's not going left or right at all. So we would say your x value is 0, but it is going down 3. So 0, negative 3 would be your coordinate. Okay? So again, the coordinates in the first quadrant are positive x value, positive y. The symbols in the second quadrant, it's x value is negative, but your y value is positive. In the third quadrant, notice it's going back, so it's negative and also going down negative. And lastly, in the fourth quadrant, it's going over positive x to the right, and then going down negative, okay, for your y value. Okay, now, how do you find the distance between 2 points? We have the formula here. The distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, how did they come up with that? When dealing with triangles, there is a specific theorem for right triangles when we're talking about the lengths of the right triangles, or the sides of the right triangle. It's called the Pythagorean theorem. Now, we're going to go more in depth later on in the book, but I have to tell you what the theorem is just to be able to explain how they came up with the distance formula. Now, the Pythagorean theorem is a squared plus b squared equals c squared. Now, I like to more so refer to it as leg squared plus leg squared. So leg squared. Oh, that's some bad handwriting there. Let me just type that out. There we go. Leg squared plus leg squared equals hypotenuse squared. Now, what that actually is on the graph is with a graph, I can actually create here a right triangle. And a right triangle is when we have a triangle that has a right angle, 90 degrees. And the two sides that make up the right angle are called legs. And the longest side opposite that is called the hypotenuse. Okay? So here we have our formula. Again, square root of x squared minus x1 squared plus y2 minus y1 squared. Well, if you think about it, how do we represent this bottom leg as a distance? Well, this distance here is the far point, which it lines up with b, your x value is x2, minus your x value for a, which would be x1. That is how we can represent this leg on the bottom. Now this one on the side, okay, so this one right here, it's if you talk about the distance from top to bottom, because that's what we're talking about, the change from top and bottom. Your top y value is y2, and we're going to subtract that from y1. So that's how we can represent that distance. So if we're looking for the longest side here, the hypotenuse, okay? So we're looking for the hypotenuse here. We can now apply our formula to the Pythagorean theorem. Apply these values to the Pythagorean theorem. So the leg going side to side would be x2 minus x1. And again, if we're using the Pythagorean theorem, we're saying that leg squared plus the other leg squared, which is y2 minus y1 squared. That's equal to our hypotenuse squared, which we don't know right now. Let's call that our distance squared, so the distance between the 2 points. Well, now if you want to get the lowercase d by itself distance, you would square root it, and whatever you do to one side, you always have to do to the other. What happens is that square root will cancel that square out. So that will leave us with our formula that we see up here, okay, for the distance formula. But now what we're going to do is we're going to put that into play with some actual coordinates on the next page. Now it says use the distance formula to find the distance between the following 2 points. And again, let's write that out. The distance is equal to, we have x2 minus x1 squared plus y2 minus y1 squared, and it's the square root of all of that. Okay? Now, it doesn't matter which one you want to make x1 and x2, so I'll just call this the first one x1, making that y1, x2, y2. And now we're just going to plug exactly into our formula to find the distance. So our x2 is negative 4, minus x1, which is 5, and we're going to put that in parentheses, squared, plus our y2 is negative 1, minus y1, which is 2, squared. We're going to take the square root of that. Now the biggest thing here to remember is that this is going to give us negative 9, but when we square that, sorry, this is negative 3, whenever you square a negative, if it's a real number, you're going to end up with a positive. So negative 9 times negative 9 is 81, plus, and that's going to give us 9. Okay? Negative 3 squared is 9. So that would be the square root of 90. Now I can take that further and simplify that. Now we're going to do that in class. But, and I'll just let you know the answer to get more specific would be 3 root 10. Or you can actually go to a decimal by plugging that in the calculator. But we'll handle that part in class. But just be able to apply the distance formula. That's what we're working on right now. Here it says use the distance formula to find the distance between the following 2 points. Again, so this is just the same problem, just a different set of numbers. I can go ahead and set that to x2 and y2 if I want. As long as the 1's and the 2's go together, that's what's important. So I can go my first x value minus the other, parentheses squared, plus y2, which is 3, minus, but notice here, you got to be careful here, it's minus a negative 2, okay, squared. I'm just getting technical with those brackets, parentheses around the parentheses. So here we have negative 6 minus 2 is negative 8, squared, plus, but on the inside here, notice when you subtract a negative becomes a plus, so that becomes 3 plus 2, which is 5, squared, and we're finding the distance there. So when you square negative 8, you get 64. When you square 5, you get 25. And again, don't forget that root is underneath it, or above it. So the distance between those 2 points, 64 plus 25, would be 89. And again, it's the square root of 89. Okay? So that would be the distance between those 2 points. And again, we plug in our calculator, go to the nearest tenth, or whatever the directions are going to ask in the homework and on the quizzes and tests. Okay? Now next is the midpoint. So we found the distance from one point to the other. Here we have the midpoint. The midpoint is the point exactly in between 2 other points. Okay? And it creates 2 congruent segments. Well, the midpoint, basically, it's like to find the midpoint, it's like the average. One x value plus the other cut in half. It's the average of the 2 points. So here, notice the difference between the distance formulas. There was a subtraction sign in between, but here we have a plus sign. So we're going to take one x value, add it to the other, and cut it in half. That'll be our x coordinate. Our y coordinate would be 1y plus the other y value, cut in half. So, which gives us 10 over 2, 3 plus 7 over 2, comma 5 plus a negative 9 gives us a negative 4 over 2. And always, if you can reduce, reduce. So our final answer, 10 divided by 2 is 5. Negative 4 divided by 2 is negative 2. So that would be our final answer right there. Okay, 5, negative 2. That's how you find the midpoint between 2 points, is take the average of the x values, take the average of the y's, and there goes your midpoint. Now, what if you know what if you know the midpoint and one of the endpoints? How do you find the other one? Okay, that's the tougher part. Well, let's look here. One endpoint of AB is negative 3, negative 2. The midpoint of AB is point M, which is 3, 4. What's the coordinate of B? So if we were to graph that, negative 3, negative 2. Sorry, negative 3, negative 2. So we have this point right here. Okay, and we're calling that A. It says M is 3, 4. 1, 2, 3, up, 1, 2, 3, 4. Again, M is the midpoint, so this continues to extend until you get to B, which they have the same distance. But the question is, how do you find that coordinate B? So we're going to do the math down here. A, we said, is, again, negative 3, negative 2. And M is 3, 4. Well, if you think about our formula, the midpoint, when I added x1 plus x2 cut in half, I got my new x coordinate for my midpoint. That's what I ended up getting. I ended up getting 3. When I did y1 plus y2 over 2, I ended up with my y coordinate of my midpoint. So we're just actually going to set up 2 separate equations here so we can find what is that second coordinate. So if we call this x1, y1, let's deal with the x's first. So we have negative 3 is x1 plus the other coordinate that we don't know over 2 gives us our x coordinate for M, for our midpoint. Now it comes down to doing the math here to get x2 by itself. So in this case, the algebraic way to solve this, we times 2 on both sides. Sorry, let me rewrite that. We times 2 on the left, which means we times 2 on the right to eliminate out of the denominator. So that gives us negative 3 plus x2 is equal to 6. And lastly, we're going to add 3 to both sides. So therefore, x2 is equal to 9. So there goes our x values. Now let's work on the y values. So our y value, y1, which is negative 2, plus our other y value, which we don't know, over 2, is equal to our y value of our midpoint, which in this case is 4. Same process. We're going to multiply by 2, so that gives us negative 2 plus y2 is equal to 8. Then we add the 2 to get y2 by itself, and we get 10. So our final answer, so whatever, we're trying to find again what b is. Our x coordinate would be 9, and our y coordinate would be 10, in order to get a midpoint of 3, 4. So again, if we followed in that fashion, we'd get 9, 10 for b, okay? If we had to graph that. But this is the algebraic way to solve for that problem. Okay, now for our last problem. Now the last problem is the same. It's just one more sample problem of the one that we just did. So we're given a midpoint, we're given an endpoint, and we have to find the other endpoint. So, again, we take one x value of one of the endpoints, which we know is 2, plus the other x value, which we don't know, over 2 gives us the x value of the midpoint, which in this case is 4. So now to get x2 by itself, we have to times both sides by 2. So that gives us 2 plus x2 is equal to 8. Now we subtract 2 from both sides. We end up with x2 is equal to 6. So we're done with the x coordinate. Now we need to find the y coordinate. Well, one y coordinate plus the other, which we don't know, over 2 is equal to the y coordinate of our midpoint. So we times it by 2, times it by 2. So we have negative 3 plus y2 is equal to negative 8. Wow, that's totally wrong math. Sorry, multiply. Is equal to negative 12. Okay? Now our last step here is to add 3 to get y2 by itself. So we end up with y2 is equal to negative 9. And that is the coordinate for y. So we know x, the midpoint is m, and we need to find point y, which now we'll write as our final answer. So y must be 6, negative 9. Okay? That would be your final answer. And again, know the difference between capital and lowercase, by the way. So when I write a capital Y, I'm not talking about a variable, I'm talking about the name of the point. Okay? Notice we're using lower cases right here and right here because those are technically variables in the problem. But we use capital letters for names of points. Okay? Notice all the capital letters are names of points. Okay? So that's how we find midpoints. That's how we find the distance between 2 points, as we did in a couple examples before. So please ask questions when you need help. Good luck.